Students, in this video, I am going to discuss about the topic morphological image processing. So this is one of the important topics in the image processing. So basically, morphology is a branch of biology that deals with the form and structure of animals and plants. So in case of image processing, morphology is used for extracting image components for representation and description of the region shape such as boundaries, skeletons, and convex cell. So basically this morphology is based on the set theory. Based on the set theory, we have morphological image processing operations. So before we discuss about the morphological image processing operations, we have to understand some of the basic operations. Here, these operations, they are totally based on set theory. First, we have an operation called reflection. So reflection of set B can be denoted as B cap. The symbol, whatever we have, is called as cap symbol. So that the reflection of set B, it can be denoted as B cap, and it can be defined as B cap equal to W. So W is some set of elements. B cap equal to W, where W is obtained as minus B. B can be treated as the elements of set capital B, such that these elements B belongs to the set B, right? So small b, it indicates set of elements belonging to the set whose name is capital B. Okay. Remember this concept. The reflection of set B can be denoted by using this particular symbol B cap, and it can be defined as B cap equal to W, some set of elements, where W is obtained as minus B. Here, small b it indicates elements of the set B. That's why here we have written that the small b, that some elements belongs to set capital B, right? And similarly, we have one more important operation called translation. The translation of operation is carried out with respect to some point. Okay. Here we use the point name as Z. Z equal to say Z1 by Z1 comma Z2. Here it can be defined like this. The translation of set B by some point say Z equal to Z1 comma Z2. It can be denoted as capital B in bracket Z. This operation indicates that B is translated by Z, where Z can be say in bracket Z1 comma Z2. It can be defined as we write as capital B in bracket Z, that is translation of set B by Z, where Z is equal to some point say Z1 comma Z2. It is equal to C. Again, C is some set of elements C, such that C is obtained as B plus Z for B belongs to the capital B. As I told earlier, small b indicates elements belonging to the set capital B, right? So reflection and translation operations, they are frequently used in morphological operations. Okay. So we'll discuss the concept of reflection and translation with respect to an image. Here we have a very good example. Okay, just you consider this as B. This is some set, right? This set, it is set of pixels. If you look at this set B, if you look at this set B, it has all black pixels, right? Some values might be 0, something like that. Okay. So right here, first we have shown reflection of B, right? Reflection of B, as we discussed, it is indicated by B cap. So here exactly we are finding the reflection of this input set B, right? The output we have denoted as B cap. This is the reflection of set B, right? And similarly, the translation of this B can be denoted as B in bracket Z, right? B in bracket Z, it indicates translation of set B by Z, where Z can be say Z1 comma Z2. Okay, if you look at this diagram, here B is translated from some point say Z1 comma Z2. Means here this translation operation is representing shifting of this object B from origin to some point say Z1 comma Z2. So this is the real operation of the translation of set B by Z. So this part is a reflection of B denoted as B cap, and this operation it indicates translation of B by Z, where Z is some point say Z1 comma Z2. Students, please remember these operations, a reflection and translation, because they are very frequently used while carrying out many of the morphological operations. Okay, if you consider morphological operations, we require one more important thing, what we call it as structuring element. Okay, in the morphological operations, there exists an input image, that is the original image. Along with this original image, we use one more sub-image, which you call it as structuring element. So this structuring element we choose depending on the expected operations. Okay. So actually structuring element, it can be set as a small set of elements, or it may be sub-images which are used to probe the image under study for some properties of interest. Okay, here we have some of the examples of structuring elements. Okay, if you look at the first one, here we have the one of the structuring elements. So this is origin of the structuring element. Okay, if you consider this structuring element, okay, if you write the values for this, here black indicates 0, 0 represents black color, and 1 represents white color, right? So this can be represented as 0, 0, 0, 0, 0. And other locations for this particular structuring element will be 1. Okay. Then this is also one of the structuring elements where all the elements they have taken value 0, that is black color. This is also one example we have for structuring element. This is also one structuring element which is going to form a rhombus type. Okay. So these structuring elements we can represent as matrix, right? So if you consider this first one, it can be represented as a matrix like this. So white color, as I told, it indicates 1. Black color, it indicates 0, right? So that this is 1, 0, 1, 0, 0, 0, 1, 0, 1. This represents this particular structuring element. And this is the matrix for the second structuring element, where its values will be 0, 0, 0, 0, 0, 0. We'll get 3 by 3 matrix where each element will be a 0, right? Similarly, this is a column matrix with elements zeros, and this is something like a rhombus. The black colors they take values 0, and white colors they take values 1. So these are called as structuring elements. Dear students, always you remember whenever we carry out any morphological operation, there exists one original image. Along with that, there exists something called structuring element. So using this structuring element, we perform some operation on original image. Okay, here basically in the morphological image processing operations, we have 4 important operations. They are erosion, dilation, opening, and closing. These are the 4 important operations, are basic operations in morphological image processing. We'll discuss these operations one by one. First, we are going to start with erosion. So again, erosion, it can be defined like this, with sets A and B in Z square. So again, this Z indicates some image. Z square means it will be a binary image. So in the image processing, particularly in morphological image processing, remember Z square is going to represent a binary image. This 2 is going to indicate that we have a binary image. Okay. The erosion of A by B, remember A is the original image, B it will be a structuring element. The erosion of A by B, it can be denoted as A, we use this particular symbol, we use circle with minus. So A erosion by B, it can be defined as something like this. This is erosion operation, symbol for erosion operation, right? So A erosion B can be denoted as Z such that it is obtained by translating B by Z, which belongs to the set A. So erosion of A by B can be defined as Z, where Z is obtained by translation of B by Z belonging to the set A. And when we carry out any erosion operation on the input image, it is going to shrink the size of the original image. Remember, erosion operation, it leads to shrinking of the original image. You can understand this erosion operation much better with an example. Here we have some of the examples. Okay, we'll discuss the examples of erosion. If you look at this is the first example we have. So here we have the structuring element. Sorry, we have the input image A. A is the input image or input set. If you look at this input set or input image, the size of this image is G. It's a square shape. Assume that it's a square shape where each side has length D, right? And B, it is the structuring element. So again, structuring element is also a small square with size D by 4. Okay. So this is A is the input image, B is the structuring element with size D by 4. Okay. When we carry out erosion operation of A by B, when we erode or carry out erosion operation on A by this structuring element B, we are going to get this as the result. I told you that basically the erosion operation is going to shrink the original size of the image. As size of the structuring element is D by 4 and size of the input image is D, so what happens is this original image whose size is D is eroded or shrinked by size D by 4. This D by 4 will be total shrinking size, right? So that's why if you look at the result, here left side D by 8, it is shrinked by D by 8. On the right side again, it is shrinked by D by 8. Similarly, at top and bottom also we can find that the input image is shrinked by D by 8 and D by 8. The total shrinking size will be D by 4. That is size of the structuring element. But at each side, if you consider this shrinking will be of D by 8. Similarly, we have one more example. Consider again the same input set A, and now if this is the structuring element, assume that the structuring element B is this particular set. So now if we carry out erosion operation, what is going to happen is this structuring element will be moved with origin. It will be moved into this original image A. This structuring element D, the structuring element B with size D, if it is moved inside the original image A, we are going to get simply a straight line like this. This is now erosion of A by B. Here we have erosion of A by B with this structuring element, and here we have erosion of A by B with this particular structuring element. The idea is that wherever this structuring element moves inside the set A, that part is eliminated, that part is shrinked. Okay. So this is the concept of shrinking operation. Sorry, it is erosion operation, you can say. So basically, erosion operation can be used to remove some small objects. Assume that in your image, you have squares of different sizes, say 5, 8, 11, 12, and so on. Suppose if you use a structuring element, a square of size 8, and when you carry out this erosion operation, all these small squares whose size is less than or equal to 8, they are eliminated from the original image. So like that, the erosion can be used to remove the small objects from the input image, depending on application. Okay. So next we have what is called as dilation. We have next operation known as dilation. So it is also one of the important morphological image processing operation. Remember, dilation is exactly opposite to erosion operation. Erosion, as we discussed, it is going to shrink the size of the original image. However, dilation is used to thicken the image. So it is going to increase the size of the original image so that the dilation operation can be represented as A XOR B with A and B as sets in Z square. As we discussed, A is the original image, B is the structuring element. So with A and B in binary image, as I told, binary image we represent as Z square. The dilation of A by B, denoted by using this particular symbol, can be defined as A dilation of B is Z. It is obtained as translation of B and translation of reflection of B with okay, here we can define like this. Just I will read out this statement, you can easily understand. The dilation of A by B is set of all displacements. This operation indicates translation or displacement by Z such that B and A overlap by at least one element. So this is intersection between A and reflection and translation of B, right? B first it is reflected, then translated by Z, and its intersection with A, which is not equal to 0, meaning that the dilation of A by B is set of all displacements Z such that B and A overlap by at least one element. The dilation operation it is going to expand the size of the image. Students, you must be able to write this equation and you must be able to define this operation as it is given in the textbook. Please try to understand this statement. I will repeat once again. The dilation of A by B is set of all the displacements Z such that B and A overlap by at least one element, right? So this is about dilation operation. We are going to discuss this dilation operation by taking an example. Okay, here we have same example as we discussed in the erosion. Again, we have set A, that is original image A, whose sides are equal to D. Then we have B image, that is the structuring element. So first, as per definition, we have to carry out a reflection of B, right? So reflection of this B is going to remain same because we have simply a square. If we take a reflection of this square, it is going to remain as it is. Okay. Then what we do is we carry out the translation of this A by B, right? So that this structuring element B, that is reflection of structuring element B, will dilate the original image A. Here what happens is, as it is exactly opposite operation, the size of this original image is increased by D by 4. That is, on each side, we are going to get thickening of d by 4. That's why if you look at this diagram, easily you can understand this uh, dotted square, it indicates original image whose size is d. Then this original image, it is expanded by d by a on all these sides. Then we have second example. Again, we have taken this particular structuring element whose length is d and width is d by 4. So now, if this structuring element is used to dilate the input image A, this is the result. That is, on the top and bottom side, on the upper and lower side of the input image, we find that it is expanded by d by 2, d by 2, because the actual size of the structuring element is d. The original image, it is expanded by d by 2 and d by 2, which is equal to d. But on the left and the right side, if you observe, as the structuring element size is d by 4, here we find that the original image on the left and right side, it is increased by size d by 8 and d by 8. So this is how the dilation operation is represented. These are examples of dilation operations. In the exam, suppose if you get the question as explain erosion and dilation, you have to give the statements with equations, and also you have to explain the examples. You better to take these two examples, and you can explain the operations of erosion and dilation. And here we have one more example of dilation, that is real-time application we have. Here we have some text. If you observe this text, the background is black color, and the foreground is white color. So if you observe this, it is something like blurred image we have. So if you carry out dilation operation, then you can observe that this text content, they are bold, right? The input here A indicates the sample text of poor resolution, along with broken characters. But when you carry out the dilation operation by using this particular structuring element, we can see that the broken segments, they are joined. They were joined. This is the result we get after carrying out dilation on this input image. Like that, depending on application, depending on the requirement, we use erosion and dilation operations with different structuring elements. Students, this is all about erosion and dilation. In the next video, I'm going to discuss about the next two operations called opening and closing. Thank you very much.